All right, so you guys remember when we were doing the electron dot notations, right? That's how we figured out what kind of ions the different elements would form. All of these, since we just started to fill in S sublevel at the highest energy level, they all have one valence electron, right? These all have two. Kind of skip the transition metals right now. We'll get more into them after break. Back. Okay. All of these have three valence electrons because we have two from the S and one from the P. These have 4, 5, 6, 7, and 8. So we call the S and the P block, we call those the main group elements because they're the ones that are currently filling in the highest energy level of the S and the P sublevel. To figure out what kind of ion they're going to form, if they were less than half full, had fewer than 8 valence electrons, then they tend to lose electrons, and that's the metals. The metals are on the left-hand side of the periodic table. So on that periodic table up there, that staircase that's up there, remember I said the left of that red bolded staircase, they're mostly metals. To the right of the staircase are nonmetals. So there's a whole lot more metals than there are nonmetals. The ones that are kind of on the staircase, some of those we call metalloids because they kind of have properties of metals and nonmetals, but we'll get into those. Okay. So we also put the charges up here. These tend to form a +1 charge because since they only have one valence electron, it's easier to lose one than to try to pick up 7 to fill up their outer shell. Remember that every element would like to have 8 electrons in its outer shell to be the most stable, except of course for hydrogen and helium, because all they have is an S sublevel to fill up. So they're the most stable formations through the electrons. But the rest of them want 8 electrons in their outer shell to fill up the S. So these, since they only have 1 electron in their outer shell, the previous energy level is already filled, so if they can lose that 1 electron, they'll be stable. Okay. Here, they have 2 electrons in their outer shell. They can lose those 2. Again, the previous energy level is already filled. 3, it's still easier to lose 3 than to gain 5. So they'll tend to form a +3 charge by losing 3. The ones that are in the 4th, or have 4 valence electrons, they could go either way, right? They could gain 4 or lose 4. They don't tend to form ions anyway. Some of them do towards the bottom. They'll end up losing. But the ones up at the top, like carbon, doesn't tend to form ionic bonds. It tends to do covalent bonding, which we'll get to later. Okay. These have 5 valence electrons. It's going to be easier to try to pull in 3 to make to fill up the outer shell rather than lose 5. So they tend to get a -3 charge. These have 6, they need to pull in 2 more to get -2. The halogens here have 7, they tend to want to pull 1 in to get a -1 charge. And then the noble gases, of course, they're stable the way they are, so they're not going to lose their electrons. Okay, so those are called monatomic ions. What does mono mean? 1, right? So they're all formed from a single atom. Let's take a look at just a couple with monatomic ions, and then I'll bring in another concept we're going to talk about, polyatomic ions. So for example, if I want to pair up, let's say, a magnesium, we did do a few of these with that chart that I gave you with the electron documentations. Okay, magnesium tends to lose 2 electrons to form a +2 ion, right? Let's say I want to put that together with a fluorine, which is -1. When an ionic bond forms, it's the electrostatic attraction, right? The electrostatic forces, positives attract negatives. Will this cancel out if I have a magnesium attracting a fluorine? Will that completely cancel the charge out? Okay, no, right? Because we have +2 and -1. So how many fluorides would I need? Need 2 of them, right? when that happens, then I just simply write the formula for the compound is MgComt2, right? Because I need 2 of the fluorides to cancel out. Does that make sense? What if I have something like aluminum, which comes from this column, and that's going to bond with sulfide, which is 2 minus. What ratio would they have to come together? 2, 3 of which one? Okay. If I have 3 of these, that's going to give me positive 9. What ratio would they come together? What's the simplest ratio they could come together to cancel out? Like if I add another sulfide, now I have -4, right? That's still positive 3. So now I have more negative charge than positive charge. If I add another aluminum, now I have positive 6.
Add another sulfide.
Right, now I'm at -6 and positive 6, right? So my formula for that one, that Al2S3. So the way you have to look at some of them is you have to look at the least common multiple. The least common multiple of 3 and 2 is 1. It's least common multiple 6, right? So I need 2 of these to get positive 6, 3 of these to get -6. Does that make sense? So that's what we're going to play around with today. But there's also ions called polyatomic ions. What does poly mean? What does the prefix poly mean?
Many.
Many, right? Or at least more than one, but many, right? So there's some ions that are made up of groups of atoms, okay? And these groups of atoms are actually covalently bonded together, but overall they have a charge and they act as a single ion. So we have more than one atom with an overall charge that acts as one ion. So for example, the carbonate ion is CO3. It's made up of a carbon and 3 oxygens all clumped together in one. Okay, so it acts as one single ion. Has a -2 charge. So, for example, I could put together, sticking with magnesium, what are these going to do to each other? Positive 2 and negative. Do I need more than one of each of them? Or are they just going to cancel?
When you need more of the first one, because that would be 6 or -6.
Okay, so this is just a clump of atoms, but overall it just has that charge. That 3 doesn't play a role in the charge. So overall, it's just this ion has a -2 charge. So it acts as one single ion. So this is just simply going to be MgCO3 because the +2 and -2 cancels out. It's a clump of atoms together, but it has one charge. So as a group of atoms, they've obtained that -2 charge right there. Does that make sense? So it acts as just one ion with that one charge. Okay. Let's say another one is nitrate. So let's say I want to put the magnesium with the nitrate. magnesium's +2, nitrate's -1. So how are they, what ratio are they going to? Magnesium with nitrate. Magnesium's +2, nitrate's -1.
Another nitrate.
Right. If I have another nitrate, that gives me -2, which will cancel that out. So when I write that formula, I can't just write it this way, because it looks like I have 32 oxygens, right? So what we do with polyatomic ions, if you need more than one polyatomic ion, you just put it in parentheses. Put the ion formula in parentheses. And how many you need outside. So that's telling me I need 2 of the nitrates. Because nitrate is a node. Does that make sense? For monatomic ions, we don't need parentheses. Like when we did MgF2, I didn't have to put F in parentheses because it is only a single atom. We only need the parentheses for the polyatomic ones when we need more than one. Does that make sense? All right, so I just want you to practice a little bit with these. I have a little. We're just going to look at the left-hand side of this. We're not going to do the whole thing. I'm just introducing it to it. So on this table over here, I just want to focus on, actually first, let's just do row 1, 4, and 9. 1, 4, and 9. We'll go back to the number 2. 1, 4, and 9. Just go across the row, and all you're doing is just writing the formula that you get if you're putting sodium with the chloride. You always put the positive one first. Okay? Always put the positive ion first in your formula, negative ion second. So if you're going to put sodium and chloride together, sodium and carbonate together, sodium and hydroxide together. Keep in mind, hydroxide is polyatomic, right? It's oxygen and hydrogen. As long as you have 2 or more atoms, it's considered a polyatomic. Give it some time to do those, and then we'll look at those together. So let's take a look at some of these, make sure you're on the right track. Putting these formulas. All right, so here you're supposed to do sodium and chloride. Sodium's +1, chloride's -1. So what's the formula for that?
NaCl.
Right, you just need one of each, right? And remember with chemical symbols, if it's 2 letters, the second one's always lowercase. So that's how you can tell if it's just an element or if it's polyatomic. If it's another capital letter, you know it's starting another element. Okay, so CO3, that's a polyatomic ion, right? Carbon. It's -2. Sodium is +1. So what's that for? Positive ones are we going to need to cancel out? 2 of them, right? So I need 2 of the sodium, but just 1 of the carbonates. So I'm just going to write CO3. I don't need parentheses around the CO3 because I only need 1 of them. Okay, but CO3 is the formula of the carbonate. Okay, sodium and hydroxide. What's the formula for that one? OH is called hydroxide. It's a polyatomic ion that has an overall charge -1.
NaOH.
Right, just simply NaOH. -1 cancel out. SO4 is sulfate. It's another one of our polyatomic ions. That has a -2 charge. Okay, so how many of the sodiums do I need to cancel that out? 2. Na2, SO4. I need 2 of the sodiums, 1 of the SO4s. What about sodium phosphate, the PO4 one? PO4 is phosphate. What's that formula?
Na3.
Right, I need 3 of the sodiums, right? Cancel out 1 of the phosphates. So Na3PO4. And then nitrate, NO3 is a -1 charge. So what's that formula?
Do anything.
Right, here's what it is. NO. All right, then let's jump down to number 4. Calcium has a +2. Just to note, a lot of times charges are written to like with the number in front, the charge after. They didn't do it on the worksheet that way, but that's typically how you see a charge. They usually put the number first and then if it's positive or negative after. All right, so here I have +2, here I have -1. So what's that formula? Calcium chloride.
Ca2Cl2.
Oh. I need 2 CAs.
Oh, no.
Yep, just 2 CLs, right? 2 CLs to cancel out the CA. All right, CA and CO3. Do I need more than one of either of them? Yeah, they just cancel out, right? So just CA, CO3. Just put it together. What about the calcium and the hydroxide, BOH? What ratio do they come together? Right. And I am going to have to put the OH in parentheses because it is polyatomic. Otherwise, it would look like I just had 2 hydrogens, but I really have 2 OHs, right? I have 2 hydroxides. Okay. What about the calcium and the sulfate? Just put them together, right? Always write the positive one first. Okay, calcium and phosphate, that's kind of like that last one, that example that we did. How many of each am I going to need there?
6.
The overall charge has to be 6. So how many of these do I need to get? 6?
3.
3 of
2
them?
for the other.
I need 3 calciums to get +6, 2 phosphates to get -6. The reason they call this crisscross is for ones like this positive charge becomes the subscript of the negative ion, and the negative charge becomes the subscript of the positive ion. So they call it crisscross. But it only works when they have 2 opposite charges. You always bring them together. In a 1-to-1 ratio, they have the same charge. So like on this one, crisscross doesn't really work because it doesn't say Ca2, CO2. Just put it together because they cancel out. But it does work for when you have 2 different charges. All right, and then how many nitrates are we going to need to cancel out calcium? Making sense? All right, then I picked number 9 because that has a +3 charge, just to change up the charges a little bit. So what's this formula going to be for cobalt chloride?
COCl3.
What about cobalt with carbonate?
CO2 and then CO3 too.
CO3.
Oh wait, 3.
2 cobalts will give us +6. 3 of the carbonates will give us -6. This one, the OH. How many OHs will we need? So, 3. And you want to put in parentheses because otherwise it looks like it's just 3 hydrogens and not 3 hydroxides. Okay, sulfate, again, it's a -2, similar to the carbonate, which is -2. So what's the ratio there? How are we going to get together? How many cobalts will we need? 2. Sulfates. And cobalt and phosphate, they're both 3, right? +3 and -3, so they just cancel out, just burn them together. And then nitrate is -1, right? So how many -1s do we need to cancel that out? Any questions on that?